Hello my dear champions, I hope you're all doing great. Okay, so today in the session of theory I have brought for all of you two chapters again, and this is going to be sequences and series and linear inequalities. Okay, so these are two simple chapters. GP part in sequences and series, and the inequalities are you can find the questions very easy. So let's try to learn the theory over here. This is again only theory lecture, so let's learn the theory over here and fill the gaps if there is any in our preparation of PU1 syllabus. About our ABHYAS test series as well as KCET 30-day crash course. So if you are still figuring out which one to take, I've taken the entire comparison over here. So basically bacha, if you are serious and you have time right now, you can prepare for your test series right away as well, from the test series right away as well. So you can take in the ABHYAS KCET test series, which is priced at 999, you can take 30 plus mock test which is there, which has both type of mock test, full syllabus as well as part syllabus mock test. In the previous year, your seniors told us that they actually found the part test very efficient, because it was given for part syllabus and they were able to complete a chapter and complete few chapters and write test on it. So part test also available as well as full length test, comprises of PC, MB, means physics, chemistry, maths, biology, all is covered over here with 30 plus mock tests. So please go ahead and take it up. If you have a good clarity in concepts, you want to just practice off questions and different type of questions just for CET, a very experienced team at Deeksha has made this. So trust me when I say one of the best in Karnataka, it is one of the best in Karnataka. Okay, so this is your ABHYAS KCET test series at 999, and for the crash course, for somebody who wants to have personal attention, individual guidance, as well as complete packaged all together, even though the series already started on 21st of March. This test series, this crash course was live from 21st of March. But if you want, if you can study still right now from today itself also, you can cover most of the things over here as well. And what is the offerings of the crash course? You are getting this at 2499. You're getting 10 mock tests. These are the mock tests which is separate from the ABHYAS. If you have taken both, you'll get 10 different mock tests over here. Okay, it's not the same thing. 10 mock tests over here. Full syllabus coverage is going to be given, means you're going to find. And good thing is that lectures over here of syllabus coverage and PYQs are recorded in nature, means you can watch at your own pace. If you have a good grasp in a chapter, you can just revise it at a faster speed. Okay, so full syllabus coverage of, and there you also have the PYQ also covered for the syllabus of PU1 and PU2 both. We have not skipped anything. Okay, and you also have live doubt classes every day, subject wise. You can again once you join, you'll get to know the schedule. So join right now, whichever is your preference. If you cannot take crash course, at least try to take your ABHYAS KCET test series. Very important and very relevant for all of you. Okay, this was the clarity I wanted to give. Now let's start the session itself. Let's start the class. So first thing is, let's talk about your definition of sequence. What is a sequence? Is a collection of the numbers arranged in a definite order, and there exists what a definite succession, means how a second number comes after the first or third number comes after the second. There's a pattern that is there. Okay, so that is called as basically some definite rule, and this rule can be varying upon arithmetic or geometric or harmonic. Okay, so in this case we'll talk about more of a geometric progression. Okay, so basically is when you have a series of numbers, a sequence of numbers which has some definite rule involved to write the next or successive terms. That's your sequence. Okay, now we can have two types of sequence. One is finite, one is infinite sequence. Good thing is that we have to discuss both of these in our syllabus over here. So finite sequence we also know, and infinite sequence we also know, and we have both. As we talk about finite, as the name suggests, the number of terms in the sequence will be limited. That becomes your finite sequence, and number of terms will be not limited. That becomes your infinite sequences. Okay, so formulas of this particular chapter is very straightforward. You have nth term formula, right? You have if you talk about just geometric progression, you have nth term formula. Okay, you have sum of n term formula. When r is more than 1 and r is less than 1, it becomes 1 minus r and 1 minus r power n. Okay, so this is the sum of n term formula. One more is there, which is for infinite terms. Okay, this is everything that it revolves around, and of course the concept of arithmetic mean and geometric mean also is there. So questions are most likely to come on the mean concept, means arithmetic mean and geometric mean concept. Okay, if you look at the PYQs or the problem statement also, most of the times those questions are preferred from the sequences, or otherwise they'll give you a sequence and they'll ask you to identify or find the nth term. So most likely this kind of questions appears in the examination. Let's look at this then. So we have general term of GP, very simple. As I mentioned, if you have the first term, that is the term A1 as A, second term will be AR. What does R represents? R represents your common ratio. Next term, as it means, because you're going to multiply R again, so you multiplied R to the first term, it becomes AR. multiply r to the second term, it becomes ar square, and so on. Okay, you'll get the last term as ar n minus 1, and if you recall, we have written the same thing over here, ar n minus 1. That is your nth term in the sequence. Okay, so this is your formula for general term. As I mentioned already, both formulas are written. General term, the formula is a r n minus 1. This formula, if you remember, as I wrote, a times of r power n minus 1 upon r minus 1. This is your sum of n terms formula. Clear, right? Very clear, straightforward result. Now, as I mentioned, most of the questions comes from your geometric mean, so we have to vitalize and give importance to this side right now, because this all you already learned in your previous grades altogether. Let's look at geometric mean now. In this, we talk about if you have two numbers listed over here. Okay, then geometric mean is a number that comes in between both a and b, same as arithmetic mean only, but the result is different, where c has a relation that is product of AB taken in root. So when C becomes equal to AB, okay, and of course, if that is the case, then what happens? ACB will be in the geometric progression. It will be a GP. So ACB becomes a GP. Then C is given by root of AB. Okay, C is given by root of AB. Insertion of a single geometric mean between two given numbers, A, B, C, B, any three numbers which are in GP, then the middle term B becomes a geometric mean, and B is given by AC. In this case, I have taken C as AB. If you want not to have the confusion, I can write the same format. Okay, I can write the same format. So if you have A, B, C, then B becomes equals to root of AC. Let's not have the confusion. B becomes equal to the root of AC. This is your geometric mean. Now, this is the case when you have only one geometric mean between two given numbers. When you have 1, 2, 3 or n geometric mean, how do we get that, sir? That comes from this relation. What is this? Check about if you have n geometric means. Basically, first term, let's say, is A. Second term is, the last term is B. The first geometric mean is G1. Second geometric mean is, let's say, G2. So on till the last geometric mean being Gn. Okay, so basically I am having a GP which has how many terms, sir? N plus 2 terms. I have how many? N plus 2 terms. So if I have n plus 2 term, can I write the last term from here? Of course I can write, sir. B equals to, last term is B over here, so B equals to A. The common ratio, because the first term is A, so I'm writing the first term as A itself, and the common ratio R power, we had what? N minus 1. In this case, N is N plus 2, so we'll write here N plus 2 minus 1. You can see here, same thing written over here. Okay, so if you have n geometric means between two numbers A and B, this becomes a geometric progression of n plus 2 terms, and if you want to write the last term or the last term of this given sequence in particular, it is given by A times of R power n plus 2 minus 1, and from here actually you get a relation for R, the common ratio, as B by A 1 upon basically the root of 1 upon n plus 1. Okay, the simple simplification, you can do that. Now, so if you have the common ratio, think about it. If you have the common ratio, so if I write the result over here, let's see, I can write G1 as, sir, A times of R or not? How come, sir? How come, sir? Think about it. My G1 is the second term, so it will become A times of R. What about G2, sir? Again, A times of R square. G3, sir, A times of R cube, and so on. So basically, I can keep going forward, writing all these geometric means, okay, as A times of R for the first, which is going to be the second term, or the first geometric mean. G2 will be the second geometric mean or the third term, so AR square. G3 will be the third geometric mean or the fourth term, so G3 will become AR cube. Same what I'm doing over here. Okay, and what is the R value, sir? The beta R value comes from here, B by A to the power 1 upon n plus 1. That becomes your R value. So this is the way to find the R value, and this is the way to find the geometric means first, second, third till the nth term. Okay, how does it come? All from the creating a geometric progression with n plus 2 terms, finding the common ratio using the relation of geometric sequence as G1 equals to AR, G2 equals to AR square as the first, second, third terms, and forward. I hope this is clear. Next, same thing is written over here. G1 is AR, R value substitute. G2 is AR square, R value substitute, and Gn is, sir, AR n. Okay, because n plus 1 minus 1 will come now. Why it is n, sir? Because n plus 1 minus n will come. Okay, that's why. So we get here n times of 1 upon n plus 1. Got it? And if you have, again, if you want to find a cumulative, basically a product of all, you get the root as g equals to root of AB is the single GM between AB. That we know that, right? If you have here, if you want to find only one, okay, then g will be given by root of AB. We learned that already. Great. So this is very much clear, sir. Let's look at the relation between AM and GM. This also, after, so question over here can be asked on nth term, can be asked on less chances, but can be asked on sum of n terms also. A formula already given to all of you. Sum of n terms of infinite GP, that I'm going to teach you next. And question on geometric means individual means which is missing. Find the mean between those the given two numbers. It will be in the variable form, of course, or it can be asked between the relation of AM and GM. Don't worry, when I practice some questions today, I'll take the account of this as well over there. So we know that how to find AM. What is arithmetic mean, sir? So if you have two numbers AB, arithmetic mean is, sir, A plus B by 2. You know that. You know that, right? Same way, geometric mean is, sir, root AB. You know that, no? If I write here, sir, AB and write here A, this is AP. Then A is given by, sir, A plus B by 2. That's my arithmetic mean. Yes or no? And if you write here A, G, B, and this is my geometric progression, then the G is given by, sir, root of AB, and this is called as geometric mean. You all agree with me? Yes? Okay. So we have arithmetic mean and geometric mean. So to understand the relation between them, we took the subtraction. Okay. So what are you gonna get? A plus B by 2 minus root of AB. If you simplify this as whole square, can you not do that? Please think about it. Root AB is there. It means my A term, basically, if I have to simplify this is nothing but do one thing, take LCM over here. So you'll get what? A plus B minus 2 root of AB divided by 2 I have. Have I done something wrong? No, I just taken the LCM over here and getting the result in the product form. Okay, the 2 into root AB, making the equivalent fraction. Now, if you continue over here, check carefully. A can be written as root A the whole square. B is nothing but root B the whole square. And what about this one, sir? This is nothing but 2 times of root A root B divided by 2. Check the numerator, sir. It becomes a whole square. So I'm getting here root A minus root B the whole square divided by 2. Same thing I've written over here. Now, if this is a whole square, this value can be either 0 or more than 0. Because any square value cannot be negative, right? So this value can be either 0 or more than 0. And how did we get this particular value? We got this value when we subtracted A and G. So when we subtracted A and G, I got something which is either 0 or more than 0. It means if you move the G on this side, arithmetic means comes either equal to G or more than G. So this is the relation between arithmetic mean and geometric mean. Either equal to geometric mean or greater than geometric mean for the arithmetic mean. I hope it makes sense, right? Moving on. Infinite GP and its sum. Infinite GP and its sum. So if the number of terms of a GP is infinite, you will not have any n value because you can't substitute that. Result simply becomes sum of the terms as A upon 1 minus R, provided that mod of R is less than 1, means from minus 1 to 1. Okay, if R value is between minus 1 to 1, then sum of infinite term becomes 1 upon A minus R. Does it make sense? Okay, now it's time to solve some questions. Let's look at that. The product of 3 geometric means between 4 and 1 by 4. Okay, we're looking for product of 3 geometric mean. So what you're gonna do, your n is what? Your n over here is 3. You're gonna write this as 4 into 1 by 4 root power 3. Check here, 4 and 4 cancels. I'm getting root of 1 power 3. Answer is 1 power 3. So answer is, sir, option C. Answer is, sir, option C. Clear? Next. Arithmetic mean of two numbers x and y is 3 and geometric mean is 1. Okay, they're saying that arithmetic mean means x plus y by 2 is 3. It means x plus y is 6. X plus y is 6. So from here we get x plus y equal to, sorry, excuse me, my bad, yeah. Okay, we have this value already, x plus y as 6. Next what we have, geometric mean is also given. This is 1. It means x into y root is 1. So xy is equal to 1. If you take the squaring both sides, how do we obtain this, sir? Squaring both sides. Okay. Now xy is equals to 1. Okay. Now we have to find what? X square plus y square. There's a formula. X square plus y square equals to x plus y the whole square minus 2xy. Check carefully, we have this value 6. So 6 square minus 2 times of 1. 36 minus 2, answer is 34, which is option A. Option A. A very simple, straightforward question. Okay. Moving on. The area and the perimeter of a rectangle are A and P respectively. Okay. Area of a rectangle is given by length into breadth. Perimeter of rectangle is given by length plus breadth times 2. There's no problem. They're saying find the inequality which satisfies A and P. Okay, sir. We know one thing. If we have two numbers, excuse me, if we have two numbers L and B, okay, excuse me, length and breadth, then if you are writing here the arithmetic mean, we know the relation, right? Arithmetic mean will be what? L plus B by 2, and geometric mean will be what, sir? Root of L into B. And we know that what we have the relation, that L plus B by 2 will be either greater than or equal to root of LB. Do you all agree? Yes. Can you find the value of L plus B from here? Yes, sir. So P by 2 becomes equal to L plus B. Substitute the value. Please check. What do we have over here? We have here, so L plus B is P by 2 divided by 2. Over here we have root of A. Why root of A, sir? Because L into B is A. So I'm writing here root of A. This value becomes, sir, P by 4 greater than equal to root of A. Please continue this. We'll get 4 on that side. So P is greater than equal to 4 root A. Again continue taking the squaring on both sides. It will become P square greater than equal to 4 square becomes 16 and root of A becomes A. So P square is greater than 16A. That is your answer, option D. That's your answer, option D. Okay, I hope it makes sense to all of you. Now this is going to be a conclusion of the chapter sequences and series. Alright, so I hope you understood the questions that I explained and the important concepts, including the formulas and everything. I tried to incorporate all the concepts which is important for all of you. I hope this is clear, right? Okay, so let's learn the linear inequality now. So another chapter which is very relatively easier, not many concepts difficult over here. So we'll see the step-by-step approach, how to solve any question when it involves modulus or whatever it is. Okay, so let's start the session right away. Okay, inequalities, when we talk about this, very simple, sir. We deal with 4 types of inequalities. For example, when we have this involved or this involved, what is this called as? These are called as strict inequalities, when it is only greater than and only less than. Okay, for example, if I talk about x greater than 2, what it means? It means start from 2 all the way till infinity. This is of course open and 2 also is open, means 2 is not part of the answer. This means that x is not equal to 2. Same way, if I write here x less than 5, what it means? It means that, very simple, sir. First of all, x is not equal to 5, and also it means that the relation goes like this: negative infinity to 5, both side open. Okay, this is the 2 strict inequality that we have, and the other ones that we have is greater than equal to and less than equal to. If applying the same cases, okay, let's say x greater than equal to 2, it means that we'll have 2 closed and go till infinity, because 2 will be also equal, so we have inclusive over here. And if I write here x less than 5, we get this as negative infinity to 5. This is going to be inclusive, this is going to be open. I hope it makes sense. Okay, so this is how we understand the 4 inequalities that we have. We have inequality number 1, number 2, number 3 and number 4. These are the 4 inequalities involved The whole chapter will revolve around this only. Now, I want to talk about one very important concept from where the most of the question comes, which is the modulus applications. Modulus, how does it work around that? So if I have, sir, mod of x less than equal to a, mod of x less than equals to a, this basically means that x has to lie between minus a to plus a. This is the first result. Understand this. How? If let's say mod of x is less than equal to 2, we have 2 less than equal to 2. If you take any value after 2, think about it, 3. Mod of 3 is how much? 3. Is it less? No. Take a number 2, take a number which is less than minus 2, which is how much? Let's say I can take minus 3. Okay. So if I want to show you, check here. This is, sir, minus 2. This is 2. Okay. If I take a number on this side, I can take minus 3, put in the modulus, it'll become 3. Is 3 less than is 3 less than 2? Not. It means that this also represents this relation, sir. Both inclusive, we're gonna put here darken circles. Means answer is what? Minus 2 to 2 again. This also represents that minus 2 is less than x is less than 2. This is the first condition. Second one, very interesting one. If you have, sir, mod of x more than a, mod of x more than a, in that case, very interestingly, you have two cases, x more than a and you have x is less than minus a. Of course, think about it. If I take an example, let's say if I take from here only I take example, let's say if I have mod of x more than 2, let's say, okay, more than 2, and if I take x value as minus 3, what happens in the mod of x? Because I'm taking what? I'm taking less than minus 2, no? If I take mod of x more than 2, then x represents what? I can go either this case or this case. So x will be less than minus 8, becomes less than minus 2. Okay, so we have x, I can take x equal to minus 3, which is of course clearly less than minus 2. In that case, if you apply modulus on this, minus 3 modulus, what happens to this? This becomes 3. And if you check here, this is greater than 2. This is greater than 2. So either you can take, sir, okay, either you can take, sir, please check. You can take either less than minus a or you can take more than a. You can take here, check example, x equal to 3, which is more than 2. Okay. In this case also, if you apply x equal to, sorry, mod x equals to mod of 3, answer comes out as 3, which is again more than 2. So you're gonna end up with, if you have basically two things, mod of x more than less than equal to a, the result will be what? You can open the modulus like this. If you have mod of x greater than a, you'll open the modulus like this. That's my conclusion. I hope it makes sense. Okay, very, very important. So what are the 4 inequalities and how the modulus works in case of inequality? I have taken over here. Next is linear inequalities in one variable. Okay, if you have only one variable involved. So simple, take 7 over there and start solving for x. Okay, we can solve this one. 3x is greater than 4 minus 7. So x is greater than what? We get here minus 3 and divide by 3 because this 3 will also go over here. So x is greater than what? Minus 1. Okay. You can plot on the number line mass 1 and on the right hand side. Same way you can solve the other inequalities also. So this is all the cases of linear inequalities in one variable. As I mentioned, inequalities which have only less than or greater than symbol are called as strict inequalities. Okay, clear? General rule for solving the inequalities in one variable. And what is that? Equal numbers may be added when you can add. Let's say if I have, sir, x is greater than 5. Then if you add plus 2 over here, I can add plus 2 over here also. It becomes x plus 2 is more than 7. Okay. Same goes. If I have subtraction also, x minus 2 more than 5 minus 2. So x is more than 3. So I can subtract or add equal numbers on both sides of the inequality. Inequality will not change. Inequality without affecting the sign of inequality. When I say sign, it means that greater than or less than. Okay, so inequality will not reverse itself, but if both sides of inequality are multiplied with or divided with same positive numbers, again let's go to this example. If I have, let's say, x is more than 5 and you multiply 2 on both sides, multiply 2 over here, here also 2, what happens? 2x will be, sir, again more than 10. Okay, if you divide also, same thing, x by 2 will be also, sir, more than, if you're dividing 5 by 2. So your choice. If you divide or multiply by the positive value on both sides, same positive value on both sides, inequality will not change. But the whole story changes over here. Example, if you have x more than minus 13, x is more than minus 13, okay, and if you write now, yeah, 1 second. No, we can continue here only. Let's write minus x is more than minus 13, okay. Then if you are multiplying over here, sir, with a sign, let's call it minus 2. I'm multiplying here minus 2 on both sides, okay. Then what happens? If you multiply minus 2 over here, it becomes, sir, 2x, and over here it becomes, sir, 26. But since you multiply with a negative value, this inequality will reverse, okay. Inequality will reverse. So basically what happens over here, you're getting here, if you divide on 2 on this side, you'll get x is less than 13. Check here, the greater than becomes equal to the less than. Example, if you have over here, one more example, you check, x is more than 5, okay, and if you want to multiply minus 1 on both sides, so you get here minus x, and you get here less than, it becomes less than minus 5. So if you multiply with the minus sign, inequality reverses, sir. Inequality is reversed. You can divide also, same results is going to be there, okay. This is the method to get the, the rules to get the solving of linear equations, okay. We can use one of these in solving the approach. Graphical representation of intervals on the number line or the x-axis, of course. When it says x belongs to a close to infinity open, what it means is there's a point a somewhere. This, of course, this side infinity is there. This side, of course, will be what? Negative infinity. When they say a close, it goes like this. Over here, closed all the way till infinity, okay. So a is closed, infinity is open. If you have both open, so you go like this. Please check second case. Negative infinity, we have a, and we have plus infinity. What they are saying, sir? Please check what they are saying. What are they saying? They are saying that open on both sides. Of course, this is always open, and this is also open. This is my answer, okay. This is my answer. Both are open. This is open, this is also open. Like, infinities are also always open. We cannot close the infinity. We don't have a definite value for it, so we cannot close the infinity. Next one. Next one you check now. Same thing. We have a to b. We have this time x belong to a to b. So go like this. This is going to be negative infinity, positive infinity. We have somewhere here a, somewhere here b. What it means is basically, what it means is a is also open, b is also open, and all the values between a and b are included. Getting it? They're both open. When we have inclusive, does the story changes? When we have inclusive, the story changes. We have over here a and b. This is plus infinity and this is minus infinity. And the story is what over here? This changes. Can I write with a different pen? Yeah. You're gonna have a closed one over here and the line joining them. Please check. Means in this case, at a and b there is a equal condition, okay, less than equal to, less than equal to, it becomes again closed one. Now this is what, when a is closed and b is open. This is a very good question. Please check. Here look, this is negative infinity, this is let's say a, this is b, and this is positive infinity. What we're talking about over here, have a look very patiently and carefully. This says a inclusive on this side, okay. So you're gonna go a full dot and move towards this side, okay. So basically if I have to show you over here, this means closed at a and move towards negative infinity, okay. What about this? Open at b, sir, and move towards positive infinity. So basically on the number line, if you have to show, sorry, not closed, open, right? Yes. This is, sir, open, okay. So basically open over here because b is open and move on this side. B is open interval, so move on this side. This is how we can arrange and understand different intervals, where it is closed, where it is open. I hope it makes sense to all of you, okay. Got it? Yes. If I have to show you on the number line over here, so just close it and move towards over here. Makes sense? Yeah. A few notes. If the inequality involves less than or greater than, we draw the filled circles. If you have equality over here, means if you have these cases or these cases, you have to draw the filled circle at the point. If you have just this and this, you draw the open circles. Okay, that's it. Okay, let's look at this question. Let's solve this one. If we have this inequality, we have to solve both together. So we're going to move 2 over here and 2 over there. We get 14 less than 3x plus 11 less than 26. Move 11 on both sides also. We get here 14 minus 11 is 3. Everything remains as it is. Comes over here 15. What we are doing over here? We multiply with the positive number on both sides. 2 and 2. Positive number. Nothing changes. Inequality remains same. Subtracting 11 on both sides. Positive number. Subtracting anything does not change. Okay. So again remains same. Again dividing by the positive number. Divide by 3 and 3. So 3 by 3. X and 15 by 3. You get the answer as 1, x and 5. So 1 to 5 both closed. Answer is option B. Answer is option B. Please check. Okay. Next is this is again two inequalities. You have to solve them and get the required interval. Let's start with the first one. We get 10x minus 35 minus 6x minus 9 less than 0. 10x minus 6x, how much is that? 4x. 35 and 9 minus 44. This is 0 by the way. Okay. Move on this side. We can move because what we are doing over here basically is moving the numbers. Okay. I can move, no problem. Only if I multiply with a negative sign on both sides, then only inequality will reverse. Everything else, inequality will remain as it is as you solve the linear equations. You know how to solve equations? Same rules apply. Only if you multiply with a minus sign on both sides, then the inequality will be reversed. So 44. From here, x is less than 11. Divide by 4 on both sides, you get this condition. Let's look at the second one. What do we have over here? 2x plus 19 less than 6x plus 47. So 2x over here, 47 on this side. 19 minus 47. Again, I'm subtracting the value. I'm not multiplying with this. So don't worry about it. 6x minus 2x. This is all the rule of linear equations, not inequality. Inequality only comes to play when you're multiplying with the minus sign. How much this will be, sir? 6. Okay. Sorry, not 6. 17 minus 9 is going to be 8, right? My bad. 8. 2 minus 28. 4x divided by 4 now. You'll have here 7. You get minus 7 x. So x is more than, combine them. Minus 7. What is the other one? 11. So more than, so closed and on this side. 11 closed and on this side. Intersection is this only. Please check. Less than minus 11 till infinity, negative infinity. More than minus 7 till positive infinity. Intersection gives me what? Minus 7 to 11. Both closed. Option is A. Option is A. And this is the conclusion of the chapter. Linear inequalities, as I mentioned, how to understand addition, subtraction or multiplication of terms on both sides, how to solve them, steps also involved, and how do we use the modulus conditions, how do we solve the problems. I have given all of that. This is a complete recall of the chapter linear inequalities for your syllabus. Okay, is it done? I hope you understand this. Let's move on. Okay, this is the end of this particular chapter.